blah, blah, blah. So we start with your center, okay? So if you have trouble, start with your center. If it helps you, put your center where you can see it, where you can see the actual parts. So we know nothing yet about this ellipse. We don't know which way its major axis is yet. But we know we can make a transverse axis like this. That'll help us out. We have a vertex at 15, negative 4. 15, negative 4. This is my vertex. So now that's telling me that it's going to be the long way x, because my vertex lies on my major axis. So I'm going to start like this. And in an add, it doesn't matter which one of these comes first, but because my x is my major axis, that's where my A goes. So my A goes underneath my x. So I can find the distance from my center to my vertex. That's A. So 15 minus 9 gives me 6. So I can fill this guy in, 6 squared. Good so far? Okay, now, I've exhausted that one. Yes?
On the view sheet, mine doesn't look like that.
Okay, I'll give you another one. Wait, that's the other one. We're going to still go through that one. This is from last night. So we had a bunch of sheets we're going to go through. So now, I've got one more piece of information. I have a minor axis length. That means this whole length is 8. So what is the distance from my center to my covertex? 4. I take it and I divide it by 2. So the distance from my center to my covertex is my B. So now I know this piece. And I'm good. I got the whole equation. Good? So don't forget, you're going to start like this. To determine A and B, it's going to be which one is the major axis. The longer axis. The bigger number.
You don't want us to determine the C?
You didn't need the C in this case because you just had to come up with the equation. So since we had A and had B, we didn't need to do C. Yes?
So when they give you the length of the minor axis, is B just half of that?
Yes.
Okay.
If they give you the length of the major axis, then what's half of that?
A.
A. Good. Your foci is smaller than A. It's not compared to B, but smaller than A because it has to be inside your ellipse. We didn't have to do the parabolas because we did that already. Now here's a hyperbola. So again, I start with my hyperbola. Let's do this together. My center is negative 2, negative 1.
Is there a fraction on the test?
No, there's not going to be a fraction on the test. I'll check. But let's get this first. Now, this again just tells me where this is located. It doesn't tell me who's my major axis. It doesn't tell me which way it's going. So I have to get another piece of information. So my vertex is negative 7/4, negative 1. Is negative 7/4 before or after this? Before. Because this is like 1 and negative 1 3/4. It's right here. And the other vertex would be right here. So which way is this going, on the x-axis or the y-axis? The x. Because it always comes off my vertex. So I start like this. My x comes first. Whoever comes first is your major axis. A always comes first on a hyperbola. And what is the recognizable difference from a hyperbola to an ellipse? The minus sign. Good. So the minus sign tells me hyperbola. And then my c squared equals a squared plus b squared, as opposed to the a squared minus b squared for the ellipse. Because now I want my foci to sit out here. Okay, so now I have the distance for A. The distance from a negative 2 to a negative 1 3/4 is 1/4. So I have A. So I need to get B. So I put my 1/4 here and I squared it. 1/4 squared is 1/16. Okay, so now B. B, I have the next piece of information, an asymptote. foot of this equation deals with x and y. My slope. So I pull out my slope, and I say my slope is 4. It's equal to the change in y over the change in x. So I come to my y, that one I don't know, that one's just going to be a b. I come to my x, and if it's negative, if you already squared it, just take the square root, leave it as 1/4. I put it over there, 1/4. And I notice I have this proportion. So can I cross multiply those and find my b? B is 1/4 times 4, 1. And that's all I have to do. And then I put my b in. Oh, one other thing. We have to do the keep change flip so that this flips to the top. Because we just don't want to leave a fraction in our denominator. If you guys leave a fraction in your denominator, that'd be okay for me. You know, if you just get that far, because then I know you understood where the A is, where the B is, where the C is. Okay? Let me see if your test has a fraction, so you don't panic. I'm thinking not. I could be wrong. I don't know the completeness of the ones, but the other ones don't have a fraction. So are we okay with this? Questions? Yes, of course. I was going to say, you're asking me questions? See, you could have stayed and done all this, and you know. Okay. Equation of a hyperbola. So that the hyperbola has the plus or the minus. A minus. So, I'm centered at the origin. That's pretty cool. So I know my x and my y are just going to be x squared and y squared. But I don't know who goes off of this yet. And x intercepts, oh well, if it intercepts this, doesn't that have to be my vertex? Because my hyperbola does not touch my covertices. Technically, we don't have them. We just need them to help draw the box. So this is a vertex. So it's going off the x. So I start like this. I have not that I have no center. My center is at 0, 0. I have nothing to say h and k offset. And then I get one more piece of information. Oh, I can find the distance to A, right? So this is 3 squared. So one more piece of information. My slope. Are you all kind of catching the slope finally? The change in y. It's worse than it looks. It's not that bad. It's not as bad as it looks. I keep saying that backwards. So my slope is 2. My change in y, I don't know. My change in x, come underneath there, take the square root of that, keep it at 3, and I just cross multiply. And b is 6. So I plug in b and I square it.
Wait, do that again? Sorry.
So, okay, so I get my slope. Are you stuck at the slope?
Yeah.
I say slope equals change in y over change in x. So that's where this is. That's actually this box up here. Watch. If you go up here and over, isn't that A right here? That's your change in x. That's whatever underneath x. So that's a 3. This guy, I don't know. That's my b. This is equal to my slope, 2 over 1. If it helps, go off the box instead, rather than the slope formula. Yes? Okay. I think this was it on that paper, right? Or in other words, one more? One more. Another one? Nope. That was it. Okay. All right. Check out square. I got a couple completely square. So, we're finding the equation of an ellipse. Ellipse, I remember, has the plus. And the A is whoever's longer. So we're centered at the origin. That's one piece of information. So we're good. And my foci exists on my x-axis. So therefore, what's my major axis? X. So I start like this. X squared plus y squared equals 1. X is my major, so my major gets the A. Okay, now my foci gives me what letter? C. they didn't tell me where my foci is, right? It's on the x, but they didn't tell me how far, right? Because it's not an intercept, right? It doesn't intercept my ellipse. But my x-intercept tells me what? A vertice. Now, here's the problem. If I didn't say my foci was on the x-axis, and I said my x-intercept was 12, and my y-intercept was 4, could you figure out who was the major? Just because which one is longer, bigger. So it kind of did a twofold thing. It told you it's on the x-axis, that's your major, but on an ellipse, the major one is always longer. So if my intercepts are at 0, 12, and 0, -12, this is my A. A is 12. 0, 4, 12, 0, and -12, 0, and 0, 4, and 0, -4. There's my 4 squared. So it is, once you decide not to be too nervous over this.
I'm nervous.
Yes, but you gotta just make sense. It really does make sense. The major difference between an ellipse and a hyperbola? The minus sign. The major axis is another one that changes. On a hyperbola, because we subtract, and it matters when you subtract who comes first, the A always comes first. So if your major axis is first, the A is underneath it. In an ellipse, it matters who's longer because in an ellipse, it doesn't matter what order I add. Okay, so now here was a nice little one for you guys to try. So I know by looking at this that it is an ellipse. Why do I know this is an ellipse? Good. I've got a plus, so it could be a circle or an ellipse, and my coefficients are different. So this tells me ellipse. So therefore, in my equation, what is my ellipse always equal to? 1. So I divide everybody by 324. Take one step at a time. That's what I wanted to identify those yesterday. That's what I want you thinking. What is this first? Of course, I told you ellipse, yes, but if you saw this and didn't know, you would be able to get to ellipse. So now we separate it. And which one is the major axis? X, because it's bigger. So we know what A is now, and always keep track of your A, B, and C if you need to find C. So I know my A, if this is squared, this is also squared, so the square root of 36, 6. Square root of 9, 3.
Do we have, like when we're doing the equation, do we have to grab the ellipse or can we just put the points?
If it says sketch, then you have to. If it doesn't, then you don't have to. Like, finding the equation, the sketch is really helpful. You don't have to fill in whatever you don't need to once you get the equation. But these are usually kind of helpful to see where's your major axis.
For this one, we didn't have to sketch.
You didn't have to, no. But now your ellipse, and your ellipse was, I see what you're saying, because all you had to figure out where your vertices were. So since it went off the 0, 0, if you can find your vertices, off the co-vertices, and then your C, remember we subtract these because we want to become inside of our ellipse. And all I'm asking again is reduce your radicals. You've got to reduce your radicals. Nice little ellipse, right? Good. Okay, then we had a parabola we didn't have to do.
No, we didn't have to do.
No, and now we have an ellipse we have to find. So let's take a look at this guy. We have an ellipse whose center. No, that was a parabola. We crossed that out. Yeah. So if you want, make your translated axis if that's helpful. There's your center. You have a vertice here. So that tells me my axis, God bless you, is my major axis is my x. So my x has to have the bigger number. So the distance from here to here, I should be able to subtract it and find my A. Now be careful when it comes over here. This is at -7. It's going to move 7 and then 1 more. It's going to move 8. So depending on which way you subtract, make sure you remember to reverse that sign. Yeah, be careful of that. That's where the sketch, I find, is easier. Because you say from here to here, 7. then one more, 8. And your minor axis length, this whole thing, is 4. So from here to here is B. So divide that in 2. That's your B. So B is 2, and I square it to get 4.
So whenever it tells you if it's like the major axis length is like 16, would the vertex be after that? Or no? Like,
The vertex would be located halfway through it. But the A itself would be half that, would be 8.
Okay.
Yeah, and then you could locate the vertex, usually given 2 other points. But yeah. Why is A 8? Because A is the distance from here, which is at -7, -1, to here, which is at 1, -1. God bless you. Now, notice your X has changed. So what is -7 minus a -1? Positive 1. What is a -7 minus a -1? Duh. Take the opposite and add. -8. And distance is always positive, right? It doesn't matter which way if you do this. Minus a -7. I'm still taking the opposite and adding. That's why I said, be careful when it crosses the axis. Go like this. If this is -7, how many to get to the 0? 7, and then to get one more, 8. See it? It's going 8 positions over. But what's happening is when you subtract, you've got to change the sign. Well, how do you find the distance between if this was at 9 and this was at 4? How do you find those distances? You can count them on here too, right? But you're crossing the pole, so you're resetting at 0 when you cross the pole. So be careful to count that extra one. Whichever way you subtract is fine. -1 minus a -7. So this is going to give us, that's not going to, I could say -1. 1 minus a -7, this is going to give you your 8. If you do it the other way, just watch, because you're coming across the axis. Okay, and I have an equation. Were we okay with this one? Major axis length. So if the major axis, the whole length is 10, what is A? Oh, this is minor. What is B? 5. So right away we know B is 5. Here's another one, Owen. Watch. Here's your center at -2, 1. Here's your vertex at 5, 1. So you moved -2 here, and how many more? 5. So what is your length? 7. So if you say -2 minus 5, this becomes take the opposite and add. -7, just take the absolute value because it has to be positive, your distance. Okay. Or if you do it the opposite way. But be careful when you cross over that axis. Okay? So we're good with that? All right. We didn't have to do a parabola. No parabolas. And we did these. Okay. I want to review. Let's complete the square. Write this down, guys. Okay. You're going to have a problem that looks like this. And I say, sketch this for me. Huh? Well, no, very similar though. So what did we say how we start? We said,
That says 128 y?
yep, yep. We said hook them together. And then do the X's. Why did I put the Y first and not the X?
Because
Well, it was
the
first.
y axis.
The X is negative. So what does this tell me this is going to be? This is good. This is going to be a hyperbola. Look at your y squared, look at your x squared. Aren't they different signs? Your y squared and your x squared are different signs. So this tells me hyperbola. It doesn't mean that my x is going to be negative when I'm done dividing by everybody, but because they're opposite signs, I have a hyperbola. If they were both the same sign, I would have an ellipse. So I put these guys together. I took care of this one, this one, this one, this one. And what do I do with this guy?
Subtract it.
Good. You subtract it to the other side. Yeah, they're going to change. So now, before I can do this, I need to factor out a 16. Y squared minus, what would this be? 8? Thank you. 8y plus something. And this guy, even though it's an x squared with a 1 in front, what's in front of it? Negative. I have to factor out the negative. X squared plus 6x plus something. I added 2 somethings, so I need 2 pluses. And now I need to complete the square. So be careful, because some of you, like on the parabola, are still always giving me a positive. Use this sign in the middle. What's half of negative 8? Negative 4. Y minus 4 squared. What is 4 squared? Now, this is trapped in here. Bring down this 16. What do I got to do to this?
You gotta multiply by 16.
Good. What is 16 times 16? Good. Okay. Now, I've got my negative. Keep your negative. If you want to keep it a negative 1, I'm okay with that. What is half of 6x? And what is 3 squared? 9. Now it's trapped by this negative 1. Negative 9. So put this in your calculator. Tell me what you get. Look, be careful. 16? That works out very nicely, doesn't it? So, again, we have a hyperbola. Is it set up the right way with the minus in the middle? Sometimes what happens is if that right side is negative, and you divide everybody by a negative, it's just going to swap the x and the y position. But because it's positive, we're good. We're going to divide everything by 16. We know it has to be equal to 1. So y minus 4 squared, and I keep it over 1, minus x plus 3 squared over 16 equals 1. And yeah, and so which one is the A, the y or the x? The y. In a subtract, it always matters who comes first. In an ellipse, it matters who's bigger, but in a subtract, because 3 minus 5 is different than 5 minus 3. So remember that subtract has a problem with commutative properties. So now, what's your center of this?
4, -3.
Always go to the x first.
-3.
-3, 4.
Wait, how come x squared is 1? Like, how come?
Because in an ellipse, it matters who's larger, because we can add them either way. In a subtract, it matters, in a subtract, like 7 minus 2 is different than 2 minus 7. So it matters who comes first. Think of it that way. So in an ellipse, it's the larger, in a hyperbola, it's who comes first. So our ellipse, our hyperbola, is going to go off of this y. Y, whatever one comes first, that's where your hyperbola goes off of. That's the major axis, right? So your major always gets the A. Think of it like that. So here I am at -3, +4, and I can make a little translated axis. Okay? So my A is 1. What's my B? 4. And I'm going to find my C in a minute. But this is enough for me to graph this. So I go up 1. This is where my hyperbola is going to go, up there, and down 1. It's going to go like this, but we don't know how wide it is. So I go over 4. So I'm at -3. Going over 4 is going to put me over here somewhere. Right over that. I make a box. Now remember my asymptotes go through here? I'm a little at the top of my screen. And this is where my hyperbola is going to go. Really, really wide. So my vertices, since I went up 1, what's my vertices? from negative 3, 4, up 1.
To negative 2.
Negative 3, 5, from negative 3, 4, down 1. Good. All I need is my vertices. I don't need my co-vertices, but I do need my foci. Now my foci uses which letter? C. C. So I use a squared plus b squared because I want this thing to be greater than my a. I'm going to push it out of that little box. So c squared equals square root of 1 plus 16, so the square root of 17 is c. Good. So since I'm moving along my y-axis here, I'm going to change my y just like you changed for this. So negative 3 plus or minus, 4 plus or minus radical 17. That's the best you can do. You don't have to separate them out because you really can't resolve them any more than that. There's my foci. Now my only last thing is my asymptote, right? So the asymptote is a line. True? So it's kind of going to look like a y equals mx type of thing. Take the y part. Guys, this is important. Take the y part, not the square. Equal, plus or minus. There's my slope. My slope says change in y. Go underneath my y. What's the square root of 1? 1. Change in x. Go underneath the x. What's the square root of 16? 4. And then just take my x part. Now because we needed to say y equal, just add the 4 to both sides. And you don't have to resolve this, you can leave it like this. That's your asymptote. Can we all do that?
Since they're like usually do all everything we have to do.
Yeah, I'll say it like in your directions. Yeah. Okay, let's try one more. You have time? Okay, questions?
I wanted to ask you, what is like the major things, like equations that are gonna be on our final?
You're only, on your final? Let's just finish this up and then I'll talk about the final. Any questions on these? So you may have to complete a square for an ellipse and then just walk through the ellipse as well. Okay? So no questions on these? All I'm giving you on your test, guys,